Welcome back. In this video, we're going to go over section 7.3, which is more on factoring trinomials. What's different in this section is that now the coefficient of the squared term doesn't have to be 1. So how do you deal with it if it's like 2x squared or 5x squared or something like that? Previously, it was just 1x squared. So how do you deal with it if it's not like that? So first of all, one possibility is that there could be a common factor. So in this example, 4m squared minus 4m minus 8, our first task would be to factor out the 4. That will leave m squared minus m minus 2. And that's something that we know how to handle, right? So we'll recopy the 4, don't forget that. And then we need a product of these two binomials. We need two numbers that multiply to negative 2. They're going to be different in sign, and they need to add up to negative 1. So negative 2 and positive 1 will do the trick. By the way, be careful that you don't get so focused on factoring those binomials that you forget the 4. It is an important part of the factorization. So that will be our full answer. So we've factored out a common factor. All right, here's one for you to try. Take a second, pause the video, try this one, restart the video, see how you did. All right, this time we've got 3y squared minus 9y plus 6. I'll begin by factoring out the 3. That will leave y squared minus 3y plus a 2. And then from here, inside I can see that we're going to have a product of binomials. We have two numbers that are the same sign, which is what that plus tells me, and they need to both be negative, so we'll have y minuses. And then I need to find two numbers that multiply to be 2 and add to negative 3. So that sounds like negative 2 and negative 1. So we have 3 times y minus 2 times y minus 1. Okay, and that will do it. Okay, one more. This time we have a common factor of 5. Also, it looks like there's an x in here. Notice, by the way, we have x cubed, and we haven't seen anything like that. So that's a huge kind of, recently at least, that's a huge tip that maybe I should be looking for a common factor, because quadratic polynomials just have degree 2. So we're factoring out 5x this time. This will leave us with x squared plus 3x minus 4. And then now we're looking for a product of binomials where they have different signs. We'll have x plus and x minus. We're looking for numbers that multiply to negative 4 and add to 3. That sounds like positive 4 and negative 1. All right, so the first kind of problem you may see in this section is where there's just a common factor that can be factored out, and that turns it into a polynomial that we're more familiar with. All right, so the second half, or the rest of this section, is when that's not the case. Like this one, we have 3x squared plus 22x plus 7. And we want to know how to factor that. Of course, there's no common factor, and that's always something you need to check for. But here there's no common factor, so how do you do it? It turns out that there's basically two ways that you can do this, either trial and error or grouping. And different people prefer to do this different ways. Some people really like trial and error. I don't especially like it because I like things that are more kind of methodical. But if you like trial and error, you're welcome to do that. So we might think, okay, well, the firsts need to be 3x squared. So it's going to be 3x and an x. And then you kind of fiddle around with the numbers in here in order to make it so that you end up with getting 7 for your constant term and 22x for the sum of the outer and inners, if you like FOIL. So what I find easier to do is to do this by grouping, and so I'm going to show you how that works, but you're welcome to, of course, use trial and error if you prefer that. All right, so here's how grouping works. It's going to be kind of a modification of the way that we did this in the preceding section, where we are looking for two numbers that multiply to this and add up to be that. Only this time, since the coefficient of the x squared term isn't a 1, we do need to take that into account. So we need to find two numbers, p and q, so that when you multiply them, you get the product of the 3 and the 7 in this case. Sometimes people call this the AC method too, because we look at this as ax squared, bx, and c. The coefficient of x squared, here they call that a, sometimes 7 is called c. So we want two numbers that multiply to be the product of a and c. 3 times 7, 21. So we're looking for two numbers that multiply to be 21, and we need to add up to the coefficient of x, which is 22. So at first, maybe you're thinking, well, two numbers that multiply to 21 are 3 and 7, but they don't add up to 22. What are two numbers that add up to 22 that multiply to be 21? 21 and 1. 21 times 1 is 21. 21 plus 1 is 22. So once you've found the two numbers, and that's the hard part, once you've found the two numbers, you rewrite the polynomial, splitting up the x term into a sum of two terms. 22x is the same as 21x plus an x. So I've split that 22x into 21x plus x. Once you've done that, you can factor this by grouping. Taking a look at the first two terms, the common factor is 3x. We'll factor that out. That leaves x plus 7. Our second two terms are just x plus 7. So depending on how much you like factoring by grouping, determine how much you like this section really. We have a sum of two terms, each of which has x plus 7 as a common factor. We factor that out. That leaves us with 3x plus 1. Okay, and that will do it. So here, what we did was we split that 22x into 21x plus an x, and then factored by grouping. In case you were wondering, like, how did I know to put 21x first instead of the x? Let's see what would have happened if we would have written it the other way. 3x squared plus 1x plus 21x, 7. If we had split it the other way, or written it down the other way, then my first two terms would have had a common factor of x, leaving 3x plus 1. The second two terms would have had a common factor of 7, leaving 3x plus 1. And then we would have had a common factor of 3x plus 1 we'd factor out, leaving behind x plus 7. So we would have gotten the answer either way. Here I ended up with the binomials written down in the other order, but the purpose of that was just to illustrate that it doesn't matter. Was it 21x plus an x or x plus 21x? Either way you write it down, it's going to work. It doesn't matter. All right, so we're going to try that a few more times because most of the time people need practice with that. So we're going to try it a bunch. All right, so here we want to find factorization for 2y squared plus 5y plus 3. So I need to find two numbers, p and q. Let's call them p and q, so that when I multiply them, I get the same as 2 times 3. 2 times 3 is 6. 2 times 3 is 6. So it's not just the constant term this time. You need it to multiply to be the same thing as the product of the coefficient of the squared term and the constant term. 2 times 3 is 6. It's to add up to be 5. Okay, two numbers that multiply to 6 and add up to 5 are 2 and 3. So I'm going to rewrite my polynomial. That 5y term, we're going to split it into 2y plus 3y. Again, if you wanted to make it 3y plus 2y, you'll be fine. Okay, so we've split up that 5y into a sum of two terms. This gives us a 4-term polynomial that we can factor by grouping. 2y gets factored out. We'll be left with y plus 1. The second two terms have 3 as a factor. When we factor the 3 out, we'll be left with y plus 1. Okay, common factor of y plus 1. And then what we're left with is 2y plus 3. Okay, so that's that. The hard part on these is factoring by grouping if you don't like it or have a hard time with it. But the main hard part is just figuring out those two numbers, the 2 and the 3 in that case. All right, here's one for you to try. We're going to factor 8b squared plus 10b plus 2. We need to find two numbers that multiply to 8 times 2, which is 16, and add up to 10. Okay, take a minute, figure out those two numbers, and then see if you can finish the factorization. So go ahead and pause the video, try that, and then restart it and see how you did. Okay, so our two numbers are going to be 2 and 8. Right? 2 times 8 is 16. 2 plus 8 is 10. So we'll have 8b squared plus 2b plus 8b plus 2. Split up that middle 10b into two pieces. Now we can factor this thing by grouping. 2b factors out, leaving 4b plus 1. In the second part, 8b plus 2, we can factor 2 out, and that will leave 4b plus 1. Okay, we have 4b plus 1 as the common factor. So that will come out, leaving 2b plus 2. Okay, one more to try. For this one, you can do all of it. Figure out what the two numbers are that we're looking for, and then split the middle term accordingly, and then factor by grouping. So take a second, pause the video, and try it yourself, and then restart the video and see how you did. Okay, so for this one, we've got 8x squared plus 14x plus 3. We're going to need two numbers that multiply to be the same as 8 times 3, which is 24. And they have to add up to be negative 14. So a product of two numbers is positive, and its sum is negative. That means we're looking for two negative numbers. 8 and 3, 12 and 2 will do. Negative 12 and negative 2 are our two numbers. So I'm going to split up the middle term. We've got 8x squared minus 12x minus 2x plus a 3. Okay, now our first two terms have a common factor of 4x. Let's bring that out. That will leave 2x minus 3. And then the next part, we have negative 2x plus 3. And I need something that exactly matches. So I'm going to factor a negative out so that we'll have 2x minus 3. Okay, now our common factor is 2x minus 3. And factoring that out, we'll be left with 4x minus 1. All right, so hopefully you see how that goes. If not, let me know and we can do more. I do have more examples for us to try, so let's try that. Here we have b minus 6b squared plus 15. So as before, one of the kind of complicating things is maybe the terms are not written down in the order that you'd like them in. So let me do that, just rearrange things so that it's a little more familiar. I'll have negative 6b squared plus a b plus 15. Okay, and then I'm used to seeing the negative sign, well, the first term being positive, but that's okay. I'll just leave it as is. For now, I just don't like that negative in the front. We'll leave it for now. Okay, so now we're looking for two numbers that multiply to be the same as negative 6 times 15. Negative 6 times 15 is negative 90. Okay, so that's where that came from. And then what else? We needed to add up to 1. Okay, so we need two numbers that multiply to negative 90 and add up to 1, and that will be 10 and negative 9. 10 plus negative 9 is 1, and times negative 9 is negative 90. We'll have negative 6b squared plus 10b minus 9b plus 15. Okay, I've split up that b in the middle into 10b minus 9b. Our first two terms have negative 2b as a common factor. So let's pull that out. Negative 2b comes out, we'll be left. Negative 2b comes out, we'll be left with 3b minus 5. Let me double check because I'm not so sure. 2 times 3 is 6. B times b squared. There's a negative in front, so we're good. Negative 2b times negative 5, positive 10b. Okay, it looks all right. Let me keep going. I need to end up with 3b minus 5. So in the back here, I've got negative 9b plus 15. If I just brought out a plus 3, we'd have negative 3b plus 5. And that doesn't look exactly the same. I need it to be exactly the same as the first part. Otherwise, it's not a common factor. So instead of bringing out plus 3, let's make it a negative 3. So let's do that. So negative 3 comes out. And so we'll have 3b minus 5. Okay, so now we have a common factor of 3b minus 5. And then negative 2b minus 3. All right, and that will do it. I kind of don't like all those negative signs in the second term, so I'm going to rewrite that slightly. This is a perfectly okay answer. I just don't like the looks of it. So I'm going to factor out a negative from that second factor. So that'll be a negative 1. And then I'll have 2b plus 3. And that looks nicer. I'm going to put this negative 1, I'm going to multiply it into the first binomial, actually. This will give us 5 minus 3b times 2b plus 3. I like the looks of that better. Some people won't like it because the 3b is in the back, but I think it looks better without all the minus signs. Okay, if you wanted to just stick with the one here that's got the star on it, that's also okay. Okay. So here, let's try one more. This one, there's a common factor, it looks like. We've got 15, 85, and 100. There's a common factor of 5. Also, I can see that this thing has degree 3, so it's not quadratic. So that makes me also suspect there's a common factor. We're going to take 5n out this time. That will leave 3n squared minus 17n plus 20. Okay, so let's think about that one now. So now we mustn't forget the 5n that is outside. And so inside we've got 3 and 20. So we need two numbers that multiply to be 3 times 20, or 60. And they need to add up to be negative 17. Okay, so numbers that multiply to be 60, and they have to add up to something negative. So we're looking for two numbers that are both negative, so that their product will be positive and their sum will be negative. So two numbers, negative, multiply to 60. Factors of 60 would be like 10 and 6, 15 and 4. This is the hard part when you're doing this, right? So give yourself a second. Okay, should get 12 and 5 after a little time. So negative 12, negative 5. Negative 12 times negative 5 is going to be 60. Negative 12 plus negative 5 is negative 17. Okay, so we're going to go ahead and split up our middle term into two terms. By the way, if you're wondering why I switched square brackets there was no special reason for that. I just did it. Okay, 5n. And then in here, maybe it's because I was thinking there's parentheses coming here. 3n squared minus 12n, there's a common factor of 3n. And then that will leave behind n minus 4. And then we'll factor out a negative 5. So that will leave us again with n minus 4. So the square brackets there just kind of make it so there's not so much parentheses. Makes it a little easier to read. Okay, 5n outside. Common factor of n minus 4 comes out. And then we'll be left with 3n minus 5. Okay, by the way, don't forget that 5n that we factored out at the very beginning. It's very common for people to just pull it out, forget about it, because they get so focused on factoring all the stuff in the brackets. Make sure that you don't accidentally leave that behind. Okay, we have just one more example, I think. So let's try this one. 16, 32, and 12 looks like there's a common factor of 4 we can factor out. That will leave 4x squared minus 8x plus 3. Okay, so I've done the easy part. Take a minute, pause the video, try this yourself, and then restart the video and see how you did. All right, so now we're looking for two numbers that multiply to be the same as 4 times 3, which is 12. And they need to add up to be the coefficient of the x term, which is negative 8. Okay, so ways of getting 12 by multiplying are like 4 and 3, 4 times 3, 1 times 12, 6 times 2. It looks like what we need. So we need the product of two numbers coming out positive, but they need to add to negative. So that means they need to be negative. So we'll have negative 2 and negative 6. Okay, so we'll have our 4 still outside. And we'll have 4x squared minus 2x minus 6x plus 3. 4 still outside. First two terms, common factor of 2x. And factoring that out, that will leave us with 2x minus 1. And then in the back part, we'll factor out a negative 3. So that we'll end up with 2x minus 1. 4 is still outside. Common factor of 2x minus 1 comes out, and that will leave behind 2x minus 3. All right, that will do it. And that takes us to the end of this section. We saw how sometimes there's a common factor you can factor out that will make it so that what's left has a leading coefficient of 1. If not, you could use trial and error if you want to read about it and then do that. You're welcome to. Otherwise, I think it's easier to use factoring by grouping. It's definitely more methodical. All right, that takes us to the end of this section. Let me know if you have any questions and have a great day.